This is Geometry, section 8.1, the Pythagorean theorem and its converse. So, I've referenced this theorem a few times throughout this year, so we're finally going to formally learn what it is today. So, the Pythagorean theorem says, in a right triangle, such as this one over here, a squared plus b squared equals c squared, where a and b are the lengths of the two legs, or the two sides that make up the right angle of the triangle, and C is the hypotenuse, or the longest side across from the right angle in the triangle. So, if this is the Pythagorean theorem, the converse would be if a squared plus b squared equals c squared, then it is a right triangle. So if I give you a triangle, and we're going to do some examples of this down below, if I give you a triangle and I say, okay, these are the three side lengths, is this a right triangle? You would plug them in to this formula, a squared plus b squared equals c squared, plug the three numbers in for a, b, and c, see if it works out. If it does, then it's a right triangle. So examples, says find the value of the variables. Well, these are the two legs, y is the hypotenuse, so I'm going to set up 7 squared plus 24 squared equals y squared. 7 squared is 49. 24 squared is 576. And that equals y squared. So we would add these together. When we add them together, we're going to get 625. So we have 625 equals y squared. So to solve for y, I need to square root both sides. And when I do that, I end up with square root of 625 is 25. So y is 25. This one over here is a little bit different because now u, our variable that we're trying to find, is one of the legs. So now we're going to set up 12 squared plus u squared equals 15 squared, because 15 is the hypotenuse, so I have that piece. So 12 squared is 144, 15 is 225. So now we're going to have to subtract this 144 to isolate the u. So 225 minus 144 is going to be 81. And when we take the square root of that, u is 9. This one, letter C, is a little bit different. So we're trying to solve for v, which is this entire piece right here. We do not know if this angle up at the top is a right angle, so we cannot say 10 squared plus 17 squared equals v squared. Instead, we have two right triangles. We have this smaller one over here and the bigger one over here. So we're going to have to solve for each of these bottom pieces individually using the Pythagorean theorem, and then add them together to get v. So let's start with this small one over here. We'll call this piece x. So if I use this triangle right here, I could say that x squared plus 8 squared equals 10 squared. So when I multiply out all those numbers, I get 64 and 100. I'd have to subtract the 64. And then when I square root that, I'm going to end up with 6. So this piece is 6. And then this piece, we'll call it y for right now. So we're going to set up 8 squared plus y squared equals 17 squared. So I have to subtract these numbers. 289 minus 264, I end up with, let's see, 225. Square root that, and I get 15. So if this piece is 15, this piece was 6. If I add it together to get v, v would equal 21. Alright, so this is what I was talking about a little bit earlier. Is the triangle a right triangle? How do we tell? Well, we're going to take these three numbers, plug them into the Pythagorean theorem, and see if it works. So how do we tell which number is which, or where the numbers go? A and B, doesn't matter what order they go in. However, C has to be the biggest number, because the hypotenuse is represented by C, and the hypotenuse is always the biggest side of the triangle. So for this, the hypotenuse would be 2.9. For this one, it would be 30. For this one, it would be 10. The other two, it doesn't matter what order we put them in, because we're just adding them together. So for this one, I'm going to check to see if 2.1 squared plus 2 squared equals 2.9 squared. 2.1 squared is 4.41. 2 squared is 4. 2.9 squared is 8.41. So when I add these together, I do get 8.41. So since this works out, yes, this is a right triangle. For this one, like we said, 30 has to be the hypotenuse, so I'm going to take 20 squared plus 10 squared, see if it equals 30 squared. 20 squared is 400, 10 squared is 100, 30 squared is 900. 400 plus 100 does not equal 900, so this is no. This is not a right triangle. This one, 10 has to be the hypotenuse, so if this is a right triangle, 6 squared plus 8 squared has to give me 10 squared. 6 squared is 36, 8 squared is 64, 10 squared is 100. 36 plus 64 does give me 100, so yes, this is a right triangle. So this last one right here, 6, 8, and 10. This is an example of what we call a Pythagorean triple. So a Pythagorean triple is just 3 whole numbers, so no decimals, no fractions, no radicals. It has to be a whole number. So it's 3 whole numbers that fit the Pythagorean theorem. A squared plus b squared equals c squared. Okay, so the most common example of this that you're going to see is 3, 4, and 5. Because if I plug these into the Pythagorean theorem, 5 is the biggest, so that has to be c. So 3 squared plus 4 squared equals 5 squared. We can see that because 9 plus 16, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 9 plus 16 does give me 25. So this is the most common example that you'll see of a Pythagorean triple. So these examples are asking, is this a Pythagorean triple or not? Start with 5, 12, and 13. 13 is the biggest, so that one has to be C. So we have to check if 5 squared plus 12 squared equals 13 squared. 5 squared is 25, 12 squared is 144, 13 squared is 169. If I add 25 and 144, I do get 169, so yes, this is a Pythagorean triple, 5, 12, and 13. 6, 10, and 8. One slight issue is that 10 is the biggest number, so these are not in order, so we have to be careful and make sure that we realize 10 is the biggest number, so that has to be C. So we have to check if 6 squared plus 8 squared equals 10 squared. We just checked that up there with that example, so yes, this one also works. This one, we don't even have to check this one because definition of a Pythagorean triple is 3 whole numbers. 4.5 and 7.5 are not whole numbers, so this is automatically no, even if it works in the Pythagorean theorem. It might work for the Pythagorean theorem, these 3 numbers might make a right triangle, but if I'm asking you, is this a Pythagorean triple, your answer is automatically no, because these are not whole numbers. And the last one for this, so 3, 5, and 2, again, make sure you pay attention that 5 is the biggest number, so we're checking to see if 3 squared plus 2 squared equals 5 squared. 4 plus 9 equals 25, which it does not, so this is not a Pythagorean triple. Alright, so suppose I ask you to find a third number so that these 3 numbers form a Pythagorean triple. So you're going to set it up in the Pythagorean theorem. 7 squared plus 24 squared equals c squared, and look for that c value, that third number that would make this a triple. So 7 squared is 49, 24 squared is 576. This might look familiar to you because these numbers were the same as the first example we did on this note sheet. So 625. When we square root that, we get 25 per c. So the third number here would be 25. 7, 24, and 25 is a Pythagorean triple. All right, 8 and 15. 8 squared plus 15 squared equals c squared. So 64 plus 225 equals c squared. 64 plus 225 is going to give us 289. And when I square root that, I get 17 for the third number. All right, this one, 20 squared plus 29 squared equals c squared. Now this one, I run into a problem, because when I add these together and I take the square root, this does not come out to an even number. So that's not going to work. The other option, in order for this to form a Pythagorean triple, is that maybe 29 is the biggest number out of the triple. Just like we had those other ones on the other page, they were out of order. So maybe this is the biggest number. We can check that by saying, okay, well, let's see if 20 squared plus b squared equals 29 squared gives me a whole number for b when I solve for it. So maybe this is the hypotenuse of the Pythagorean triple. So 20 squared is 400. 29 squared is 841. So I'm going to have to subtract this over here. And when I do that, I get 441. Square root of that gives me 21. So my Pythagorean triple would be 20, 21, 29. All right, the same thing is going to happen over here with 35 and 37 if I set it up like this. It's not going to work out. So when that happens, you have to set it up like this and say, okay, well, maybe that biggest number is the hypotenuse out of my triple. So I set it up like this and solve for that second leg. So when we do this one and subtract whatever this number is from this number and take the square root of all of that, what we end up with here is 12. So this triple would be 12, 35, 37. All right, the converse of the Pythagorean theorem, part 2. So we already sort of talked about the converse of the Pythagorean theorem, because the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. So the converse says if x, y, and z are the lengths of the three sides of any triangle, so I give you a triangle and I say, okay, the sides are x, y, and z. And z is the longest side. If, we already talked about this part, if z squared equals x squared plus y squared, so if the longest side squared equals the other two squared added together, then it's a right triangle, because this is basically the Pythagorean theorem, just changing the letters. So Pythagorean theorem would say this. This is the exact same thing, just changing the letters. So if this happens, it's a right triangle. If you plug in those numbers and you get that z squared, or the longest side squared, is greater than the other two added together, then that's going to be an obtuse triangle. Obtuse meaning greater than 90, so that triangle is going to have an obtuse angle in it. And z is greater than a hypotenuse would be. So if we think about it, if I take a right triangle, and this is z, but then I extend z so that it's a little bit bigger, this angle is going to have to stretch out in order to create a triangle. So this angle is now bigger than 90. Opposite of that, if we find that this is smaller than the other two, so if I start with a right triangle and then I decrease the size of this third side, now when I connect it to form a triangle, this becomes an acute triangle, where all the angles are less than 90. Okay, so z becomes smaller than a hypotenuse would in a right triangle. So to test this out, given the three sides, classify the triangles as acute, obtuse, right, or not a triangle. This part we don't have to worry about for these three examples. We've talked about this. We talked about this earlier in the year. So, for example, if I give you the sides 1, 2, and 5, and I say, what kind of triangle is this? Well, these three numbers would not make a triangle at all, because 1 plus 2 is not greater than 5, which we talked about is a requirement for three numbers to make a triangle. Any two numbers, when we add them together, have to be bigger than the third number, which this would not work. But that condition is satisfied for all of these combinations of numbers, so we don't have to worry about that for this. So we're just deciding if it's acute, obtuse, or right. So we always have to put the biggest number on its own. So we're comparing 10 squared to 8 squared plus 7 squared. 10 squared is 100. 64 plus 49 would give me 113. So 100 is less than 113, which would be this part of the converse up here. So this would make this an acute triangle. 1, 2.6, and 2.4. 2.6 is the biggest one, so I need to compare it to 2.4 squared plus 1 squared. And when we do this, we end up with the same thing on both sides. When I add these together, I get 6.76. This squared is 6.76. So since this is equal, this is a right triangle because it fits the Pythagorean theorem. This one, 10 is the largest, so I'm comparing it to 3 squared plus 9 squared. 100, 9, and 81. 9 plus 81 is 90. 100 is greater than 90, so that's the first part of the converse up here. If z squared, or the largest side squared, is greater than the other two sides, this is an obtuse triangle.